Alright, so in this video we are going to talk about finding x and y-intercepts from a graph, which is a lot of review, so this video should go pretty quick. We're going to talk about y-intercepts and x-intercepts. Y-intercept you should already know. X-intercept is almost the same thing, just a little bit different. We're talking about the x-intercept. But go ahead and write these definitions down for y and x-intercept, and then obviously you're going to want to write down what I do on this slide as well. So let's go ahead and get started. Let's identify the x and the y-intercept. First off, the y-intercept, just like we were talking in y equals mx plus b, and the slope-intercept formula, the intercept was b, but it was specifically the y-intercept. And so we've talked about that. It's where the equation, the line here, crosses the y-axis. That would be this point right here. In this case, would have been 0, 2. And we talked about this in previous videos, how the y-intercept has a y value, but the x-intercept is always 0. All right, and that is for the y-intercept. Again, one more time, the y-intercept has a y value, and is where x is equal to 0. The x-intercept is very much like that. The x-intercept is where the line crosses the x-axis. That would be this point right here, and that would be the point 4, 0. And 4, 0, again, has an x value where the y value is 0. Okay, so the x-intercept has an x value, and the y value will always be 0. And that's just because the x-axis goes through the y-axis at 0, and so the y would be 0. So that's it, the y-intercept, and that's the x-intercept. One more time, the y-intercept has a y value where x is 0, and the x-intercept has an x value where y is 0. Make sure you have that down. It's going to be really important for the next few lessons. So, x-intercept and y-intercept, we're also going to review slope and how we describe graphs. So let's take a look at the x-intercept here. The x-intercept, again, is where the line crosses the x-axis. And remember, x-intercept has an x value and where y is 0. So let's go figure out where this line is crossing the x-axis. And y is 0. Well, y is 0 is right here, and that's 1, 2, 3, 4. So this is at the point 4, 0. And so our x-intercept is at the point 4, 0. Our y-intercept is, again, the y-intercept is where the y has a value and x is 0. So we're going to be at the point 0, something. Let's go take a look. The y-intercept is where it crosses the y-axis. That's right here, and that is at the point 1, 2, 3, 4, 5, negative 6, right? So that's going to be at 0, negative 6. The slope, I always go through the process of saying, is it positive, negative, no slope, or 0? This is a positive slope, and then we find the slope by doing the rise over the run, the change in y over the change in x. So the slope would be, I'm going to draw my right triangle in here really quick. Our run, it looks like, is 1, 2, 3, 4. That's my run. My rise is a 1, 2, 3, 4, 5, 6. So my run is 4, my rise is 6. Remember, it's rise over the run. So my run is 4, and my rise over there is 6. And this does reduce. 6 over 4 is going to be 3 over 2. And I'm going to leave that as an improper fraction. So 3 over 2 and positive 3 over 2 makes sense because it's a positive slope. Describe the graph. Well, there's lots of things we could say. We could say it's increasing. It's got a positive slope. We talked about the x and the y-intercepts already. As we go from left to right, it's going up, so it's increasing. Is it linear? Yes, it's a straight line, so we'll say it's linear. And is it a function? That's another one. It's definitely a function because it does pass the vertical line test. So those are all things we could use to describe this graph. Move forward. Why don't you guys go ahead and pause the video and give this one a shot. Woohoo! All right, so here we go. This one's a little bit different. This one's definitely not linear. I'm going to go ahead and point that out right away. So really, I want you to ask yourself this. Remember, slope is a rate of change, right? And so slope would mean that it has a constant rate of change, meaning that it's linear. So does this really have a slope? No, this doesn't actually have one, so I'm going to say that's not applicable to even ask because it doesn't have a slope. If I were to try to find the slope at any point, it would be positive because this looks as I go from left to right, it does go up, and so this would be increasing. It's still a function because it passes the vertical line test. right? And so let's get into the nitty-gritty here. here. X-intercepts. X-intercepts, again, are when the graph passes the x-axis. Now, I know this is kind of a sketchy line here, but it doesn't look like it actually ever crosses the x-axis. It looks like it kind of just starts touching the x-axis, but it actually doesn't. This is what we call, what we'll get into in a little bit, is called an exponential equation. What's happening here is that it's getting really, really close to the x-axis, but it never touches it.
Would you say it approaches?
I would say that it approaches it. Again, it keeps on approaching. It gets closer and closer and closer and closer and closer, but it never actually touches or crosses the x-axis. So this is another case where an x-intercept is actually not applicable. It doesn't have any. There are none. So if you said not applicable or if you said none, that would be fine. The y-intercept is where it crosses the y-axis, right? And again, we said the y-intercept is where x is equal to 0. And it looks like it does cross the y-axis. So it's going to be at 0 comma something. So 0 comma 1 right there is our y-intercept. Again, it doesn't have a slope. And that's probably the best we could do to describe this graph at this point. We could probably say it's positive, only because it's increasing. And increasing and positive go together. So let's try another one. All right, go ahead and pause the video and try this one. All right, so let's find the x-intercept. Oh, wait, does this cross the x-axis? I don't think so. It doesn't cross the x-axis at all, so there are none here. What about the y-intercept? Does it cross the y-axis? Well, this is the y-axis. Again, if you forgot, this is the x. It doesn't cross the x, but it does cross the y-axis right there. So this is at the point 0, comma, and it goes down to 2, so it's negative 2. So again, our y-intercept always has x as 0, no matter what, and then a y value. In this case, the y value was negative 2. The slope. A quick slope song. Positive, negative, no slope, 0 slope. This is a 0 slope. M equals 0. And then let's describe the graph. Is it linear?
Very liney.
Looks like a line to me. It's linear. Is it increasing, decreasing, constant, or neither? This is constant. We already got the slope as 0. Is it a function? It passes the vertical line test, so this is a function. Is it positive, negative, no slope, or 0? Talked about that already. We've got our x and y intercepts done and our slope, so this is about all we can tell about this graph. All right, go ahead and pause the video and try this one. All right, hopefully you did that. All right, here we go. Our x-intercept, does this cross the x-axis? Yes, this is our x-axis here, and the line comes down, and look, right there is where it crosses the x-axis. So let's go ahead and see what point that is at. 1, 2, 3, 4 to the right. Remember that the x-axis has an x value, or the x-intercept has an x value, or y is 0, so we're at 4, comma 0. So our x-intercept is at 4, comma 0. Does it have a y-intercept? No, it doesn't. The y-intercept is just going to be none. There are none, or not applicable, and it doesn't cross our y-axis here. All right, what about the slope? Well, slope song, positive, negative? No slope. This is no slope. It has all rise and no run. And rise, anything divided by 0 would be undefined, or no slope. Let's describe the graph. Is it linear? Sure.
Very liney.
Looks like a straight line to me. Is it increasing? Decreasing? Is it constant? No, none of those, right? So if I were to ask you all those things, is it increasing or is it decreasing or is it constant or is it neither or none of these, right? I would say none of those, right? Neither. So not linear, it's linear, not increasing or decreasing, constant. Is it a function? No, this is not a function. It does not pass the vertical line test. I think that's about it for that one. Woohoo! All right, go ahead and pause the video and try this one. All right, x-intercept. Does this cross the x-axis? Remember, this is the x-axis here. And it looks like, oh wow, it actually crosses twice. So how many x-intercept?
If there's 2 of them, how do I write it?
I'm just going to write 2 ordered pairs. So my x-intercept is 2 ordered pairs here. And because I have 2, I can use set notation because I'll have 2 answers, right? And so let's write out those ordered pairs. I'm going to start with this one here. That's going to be at negative 2, comma 0. And then this one right here is at 2, comma 0. So let's write that out really quick. I've got negative 2, comma 0, And I've also got the ordered pair 2, 0. Again, the x-intercept, remember, always has an x value, but the y value will always be 0. If you want to, you can throw this in the set notation because you have 2 answers there. That's perfectly fine. Or you can just say the x-intercepts are -2 and 2. However, knowing that it's an ordered pair because it's on an x, y grid, we'd like to see the ordered pairs. Let's go over to the y-intercept. Looks like it does cross the y-axis at one point, and that's right here. And that's at -3. But remember that the y-intercept always has a y value and x is always 0. So let's see here. So 0, -3. That's this point right here. All right, does this have a slope? Well, it's not linear. So slope is just going to be not applicable for this one. Describe the graph. It's not linear, just like we just said.
It is a parabola.
It is actually what we call a parabola, and you'll look into those in 10th grade.
We're just going to call it neither.
We're just going to call it not linear for now. Is it increasing? Well, it is increasing right here, but it's decreasing right here. So is it increasing, decreasing, constant, or neither? Well, it's not going straight across either, so we're just going to say neither to all of those. Is it a function? This actually is a function. It passes the vertical line test because it keeps on going up and out. All right, that's that one.
Brilliant.
Ready to pause the video? Try this one out. All right, x-intercept. Do you see this graph crossing the x-axis anywhere? Because I sure don't. The x-axis would be right here. This line, whatever we got going on here, this graph is not crossing the x-axis, so there are none. The y-intercept does have one of those. It does cross the y-axis right here, and that is at the point 0, 1. Again, all y-intercepts should be 0, some y value. In this case, it's 0, 1. There. And then our slope. Well, it's kind of like I have 2 different slopes here. I have this negative slope, then I have this positive slope. I'm going to go ahead and say there's none here, or not applicable.
Not a constant slope because
not a constant
it doesn't go
slope.
all the way into the equation.
Because this is like it almost looks like a -1/1, and then it goes to a 1/1 slope here. So there are slopes here. There's just 2 different slopes. And because it's not linear, we don't usually talk about slopes without it being linear. So again, coming to that, it's not linear. That's describing the graph here. Is it increasing, decreasing, constant? Neither. Well, it's decreasing, and then it's increasing. So I'm going to go ahead and say neither of those. Is it a function? Yes, because it passes the vertical line test.
That's very funky, that function.
Yeah, it's funky. Yeah, that's about it here. So positive, negative, no slope, or 0 doesn't really apply because that describes the slope, and it doesn't have a slope. It is negative here and positive here, so I'm not going to use any kind of descriptor for that.